All right. I'm Dan. I'm a Java developer at the LMAX Exchange. And today, I'm going to talk to you about SSL. In particular, everybody's favorite thing to do with SSL, which is, of course, to not use SSL. And when I say people like to not use SSL, unfortunately, I don't mean everybody just really likes using TLS. For those not familiar with the distinction, TLS is what used to be called SSL. It was actually renamed back in 1999, mostly because Microsoft don't like the idea of any standards named by Netscape. So the name was changed, the numbers were reset. TLS1 is better than SSL3. Everybody still says SSL when they mean TLS, and it's all very confusing. But aside from the names and the numbering, there seems to be a lot of confusion about what SSL or TLS is actually there for. People think it's there to provide encryption, which is not strictly true. The encryption is very important, but that's only part of the story. Unfortunately, you can't sort of sprinkle some crypto and make everything nice and secure. Ultimately, it's there to allow you to more safely talk to strangers on the internet. For example, if Bob wants to talk to Amazon, maybe give them his credit card number, he wants to do that in a safe way. And one problem he may find is that when trying to talk to Amazon, he's just talking to somebody who looks like Amazon, but is actually evil. Fortunately, Amazon use HTTPS, so Bob's browser is going to protect him. Aside from the crypto, it's going to make sure that when he tries to connect, he's presented with a certificate that's signed by a trusted authority and is actually for Amazon. If you don't do both of those checks, then the whole security of the system falls down, and you're only very slightly better than plain HTTP. And this goes for any time you're using a TLS-protected protocol. So if you have some client which is making REST calls or something to an HTTPS endpoint, those two bits of validation are very important for that as well, which is a nuance which is often kind of lost when people are building applications, because usually what happens is you try and connect to some system, you get a certificate error, and you think, I'll just turn off validation, and then everything will work. And everything will appear to work. It's just not immediately apparent that you've silently removed all of the security. But if you look on the internet, you'll find there's loads of tutorials like how to not do trust validation, which if you skip that, then the attacker can just make their own certificate and your client won't notice. But these tutorials, they tend to be quite well received. Like if you look at the comments, you see things like, oh, you solved my biggest problem on the project. Or, yeah, I just did a copy and paste and it works fine to connect to HTTPS URLs. This helpful commenter just also provides the code to not do host validation either. So if you don't do host validation, then the attacker can just buy a certificate for any domain that they control, and your client won't notice. And this kind of thing is far from an isolated instance. There's loads of examples of these out on message boards and Stack Overflow. This is a nice one for demonstrating some of the confusion people have. It seems to be an SSL problem after all. If I run curl-k on paypal.com, it works. I can establish a secure connection, just ignore the certificate. This then goes on to what's probably my favorite quote on the internet at the moment. The session is still secure, but I'll be open to a man-in-the-middle attack. Now, man-in-the-middle attacks is the attack that SSL was invented to protect you against. And it would be nice to think that when people write code that is skipping the validation, it never actually makes it into production. But you know when people are writing this code, it's inevitably going to make it into production. And you end up with amusing headlines like this, which is a bit of research that came out of DEF CON last year. This is another great quote. While the fridge implements SSL, it fails to validate the SSL certificates. This was the Samsung smart fridge that synchronizes with your Google Calendar, but it didn't do HTTPS correctly, so it would leak your Google credentials. And even if you actually try as hard as you can to do this right, sometimes the underlying APIs just make it very difficult for you. Like probably not a lot of people realize that the standard libraries for doing HTTPS in Python didn't actually do HTTPS correctly until about a year and a half ago. Here's an amusing little bug from this is the Amazon Payments client APIs. They're trying to do everything right. You see, both options are set to true, verify peer and verify hosts. Unfortunately, one of these options is not like the other. One of these options is actually a long. It should be verify host equals 2. True means 1, which means false. PayPal had the exact same bug in some of their client code. In Java, we've got the SSL socket factory, which it lets you open a socket which is TLS protected. And it does the trust validation for you. Unfortunately, it doesn't do the host validation for you. And it doesn't really make it clear that that needs to be done separately. So even experts who use this API end up not doing that, and it's done in an insecure fashion. Like the Apache HTTP client didn't do HTTPS in a secure way until version 4. That's probably one of the most popular ways of making HTTPS calls from Java applications. There's the book on how to do Java in a secure way, and they have an example where they tell you to use SSL socket rather than regular socket. They've got their example of using the SSL socket factory, but they don't do host validation either. They've actually added a note to their website. SSL socket does not validate host names, so it's still vulnerable to man-in-the-middle attacks. Unfortunately, that note didn't quite make it into the print edition of the book. But given that experts still get this stuff wrong, there are some people presented at the B-Sides conference in Las Vegas last year, where they've made this site, checkthatcert.com, where they're sort of bringing together various bits of like advice on best practices or bad practices to avoid for how to do TLS or SSL correctly. So if you find yourself with certificate problems, it might be better to look at some of the things suggested on there rather than jumping to disabling validation. Thank you. If anybody wants to chat later about this, I'll be in the pubs.
Slides available?
I can make them available, yeah. I'll tweet them.